Hi there. So we're looking at find a volume of a solid revolving revolution generated by revolving the region in the first quadrant bounded by the x-axis and this graph. So here's this graph. It kind of goes from here, the origin, and down here to 9, and it stops. But the trick of this question is they want you to revolve this around the line y equals -3, right? So it's basically, instead of revolving it around the x-axis and sort of taking a scenario like this, like this is our area right in here, right? So all this whole thing, okay, all right. But they want us to revolve it a bit further, right? It doesn't revolve around this axis. It revolves from down here where y equals -3, okay? So basically, I'm going to take my axis and move it down, and this now becomes my axis of revolution. But this is still my volume up here. And that will now be moved around and rotated. So basically, how do I get this large red volume? It would be, I'm basically going to include this entire volume, right? And then I'll remove this volume here like that. So basically, this thing, let me change that. This thing is the red volume, and then I'm going to take away the green volume and effectively rotate that remaining volume around the axis. So remember, a volume of rotation is a pi, and you take your radius squared. This +3 is added into here. Notice it's not up in the formula, but it's added into here to effectively take my function and bump it up 3. So what I've done is I've bumped it up 3 there. And then effectively, if I can take out this volume here, this is a very easy volume to do. It's just going to be radius of 3. This is going to be a cylinder when I rotate this whole thing around, right? This is going to end up being a cylinder right here. And it's got a height of 9 and a radius of 3. So that's just going to be 81 pi. So that leaves this basically as my final, the setup for the whole thing. So now the trick is well, what do I do? Well, this is a binomial squared, so I could expand it into this, all right? Now, this guy right here is a funny little integral that I've brought off to the side. The 9 I've brought down to here. This thing I've multiplied through and gotten into this. Now, if I go ahead and I integrate these guys here, you can kind of see 9x squared, the x to the third, the 9, and therefore I end up with this. The 81 goes here, this ends up being here, and that these are evaluated from 0 to 9. So that's pretty easy, this stuff right in here. This integral here I've done in this box, and it requires us a u substitution. So how do I get from here to 1944 pi over 5? Well, that's this thing here. So I'm going to do a u substitution. I'm going to take this and substitute it for u. Then I'll solve for x. I'll differentiate both sides. Then I'll go back and I'll substitute all this stuff in. So x equals this thing, according to that formula. Root of 9 minus x equals u, according to that formula. And dx equals a -2u du. So that's what that is. Now, cleaning up some of this stuff, the 6 I pulled out, right? I also changed my limits of integration. The 9 becomes a 0, and the 0 becomes a 3, because of basically this. If x equals 0, u equals 3, using this formula. And if x equals 9, u equals 3, again, using this formula. And so, basically, what are we going to do now? So now we're here. We clean this up. The negative u gets pulled in. The 2 I brought out to the front. So the 6 times the 2 becomes the 12. This u squared times a u and another u becomes u to the 4th. The 9 is a u squared. The negative, I went ahead and brought it into here. And now I integrate this. Okay. And this, by the way, is a negative because my integral here, my lower bound is higher than my upper bound. So you always get a negative integral if it's 0. And here I just evaluated, it's 1944 over 5. Take that, put it over here.